services. So ability to, so if this is all H. Hi, I'm George Crump, lead analyst with Storage Switzerland. This is another in our series of Chalk Talks on various technologies around the industry. Today, we're going to talk about the recovery lie and how not to fall for it. So recovery is an interesting thing because obviously it involves backup and all of these really intertwine together. I always worry when vendors say, oh, well, backup's all about recovery. Well, it's not if you didn't get a good backup. So it's really, recovery is all about everything. It's everything has to work as it did. So let's kind of architect a basic backup strategy. All right, we'll have a series of servers here, probably connected on a network. And at least for the last 10 years or so, those servers were backed up to tape. And tape took all the blame for everything that was going wrong in the backup world. About 5 years ago or so, we started to come up with this concept of disk-based backup. And so we put a disk in here with maybe a drain off the tape, and everything was supposed to be great at that point. The problem is this disk capability helps part of the problem, but it doesn't help all the problem. For example, there's still the question of how to get data off-site. There's also still the question of how do I recover data, right? One of the things that the disk backup market, or that really made the disk backup market, was the advent of a technology called deduplication, where redundant segments of data were identified and then only stored once on the disk. If you think about a full backup, it's basically the same, 90% the same as it was today, as it was last week, as it was the week before that. So there was a big cost savings there, and you could store a lot more virtual backups, if you will, on the disk. But the problem is in recovery, it all has to come back. In addition to it all having to come back, in many cases with this disk backup type of technology, it all has to go there as well. So that if this is a 100 gig server, and this is a 500 gig server, and this is a 1 terabyte server, and this is a 4 terabyte server, all this data, every time we do a backup, at least a full backup, has to be transmitted across the network to the storage device. Now, most of the storage devices here eliminate at this point, and so we still need to build a pretty big infrastructure, and that really sets us up for problems as the backup occurs. So we'll still see a lot of backup failures during this process. So we end up with a problem here of we're sending a lot of data across the network. If we need to recover, we have to send a lot of data back across the network. We're still not 100% sure how to solve the DR problem. Now, these deduplication devices help a little bit because they can eliminate the redundant data here and transmit only the net new data, so that does help. But really, if you think about it, all we have in the remote site is just the data. We don't really have anything that we could actually recover to or do anything with, so that becomes a challenge. So really, the solution here is to, number one, we have to have smarter backups. And number two, we have to have the ability to better test. Testing becomes important because in this scenario, right, if we need to test a recovery, let's say we're going to test the recovery of this 4 terabyte server here, I have to stand up a temporary server. I have to make sure it has 4 terabytes of disk capacity. And then I have to restore 4 terabytes of information. First of all, a lot can go wrong in that situation. And then second of all, maybe more important, I have a very time-consuming process. You don't transmit 4 terabytes across any type of network very, very quickly. And so the problem is you're not going to test that very often. You don't have time. You're busy doing other things. And so, you might have if you're really good, you might have a quarterly test plan. Most people have an annual test plan. And so the problem is that these things aren't tested regularly. And sure enough, the one that you haven't tested the longest is the one that fails and you have the least experience with. So that also becomes a challenge. So we're going to talk a little bit more about the ability to test. And then, and of course, finally, smarter recoveries. Okay, through the magic of editing, we've cleaned up the board a little bit so we can kind of look at our new approach. So what if we took the appliance model that's been so successful with file servers and different things like that and applied it to backup, right? And so we had an appliance back here that was intelligent. And then for smarter backups, so that would help us get installed quicker, up and running faster, things like that. And then for smarter backups, instead of transmitting this whole 100 gigs over every single time, or whatever the incremental backup might be, let's just transmit just the data that's changed. So the way that would look would be, this backup appliance would have disk attached to it. And then, of course, the first backup we would do would be 100 gigabytes, 200 gigabytes, 1 terabyte, and 4 terabytes. So once we got that first backup done, all we would have to do is essentially update our copy. So we did our first 100 gigabyte backup. The next day rolls by, we've changed a couple of documents, added a couple of rows to a database, done some things like that. Well, that's a very small fraction of a change. Well, just those little bits of change have to be updated. Same thing here, and here, and here. So the result is, now I'm sending significantly less data across the network, yet I'm getting essentially a full image of the environment here. Now down here we can set those images up so that we can get back to point-in-time copies and things like that. Now let's roll in disaster recovery here. We can have another appliance, and that appliance can again have disk. And then we can replicate again just those changes. So again, we have essentially mirror images of the environment over in the disaster recovery site as well. So that gives us smarter backups. We're done a little bit quicker. We don't need to invest as much in our network. We've got real full images here. Now let's talk about the ability to test, because that's only part of the equation, is getting the backup done. Now let's talk about testing. To me, testing is the most important part of backup, because if you can't test and know it works, the last thing you want to do is find out that it might or might not work when a system is down and you have to recover. So the ability to test, to me, is one of actually the more critical aspects, because it really verifies the whole process. And backup without verification really isn't backup. So how do we do that? Well, what if in this virtual appliance here, we could build a virtualization layer that could host images of these servers. So we have the entire disk image down here, so all we have to do at that point is create virtual machines for any of the hosts that we're backing up. Now, if I decide I want to test one of these servers, let's say I want to test this 100 gig server, the guy we've been kind of picking on, all I do is launch him as a virtual machine right in place. I don't need to copy data anywhere. I don't need to go acquire new hardware. I just start up a virtual machine right on the backup appliance, run my application, and make sure everything's working. So not only have I tested a recovery of data, which is essentially just making sure you can move it from point B back to point A, but now I've actually tested the application running to make sure that, okay, the data is there, and guess what? I bring up SQL or Exchange or Oracle or whatever, and it actually can access and use that data, right? So that's a real recovery, except the whole thing happens in, a few minutes, because I don't need to move data anywhere. I just light up a virtual machine. Well, this changes the testing process, right? Because now I don't need to do a quarterly event and hope it works, or a year-end thing which ends up being some kind of weird pizza party. Now I can just, every day if I want to, light up one of the virtual machines and have it work. So that's really powerful in this aspect. And I think, in my opinion, that's the most critical part. But recovery, of course, is important. So let's talk about two aspects there. First of all, let's talk about the worst case scenario here, a server down. Let's say that middle server disappears on us for one reason or another. Well, I've got two options. I can replace it and go through the recovery process. Again, no magic here. I still got to pull all the data back. Or I can turn on this virtual machine and present a virtual image to the users that are connected to that server. So within minutes, I can provide the service that this machine was originally providing. Now, I may not be providing it at full performance. There may be some compromise there, but some performance is better than no performance. So if there's a bit of compromise in total performance here, I think most users will accept that for the fact of being back up and running so very quickly. Now, what's interesting is while this guy is standing in, we can take a new virtual machine, a new physical machine, and replace it and have that recovered in the background. And then once all the data is back, I can kind of transition the process. So again, recovery very quick. The key point, in my opinion, for recovery is to return the service that the user was expecting as fast as possible, right? Maybe at compromised performance, probably in many cases they won't notice it, but that's the key thing. And then eventually bring in a hard machine if you need to and recover. So now let's take that same model into our DR site, right? So essentially for one reason or another, all of these systems are down and we need to bring our DR site up. Same situation. We've got essentially a hypervisor running on the appliance here that can host virtual machines, and I can bring all or some or the most critical virtual machines online instantly and then have users start remotely accessing those systems. And again, all the data has been replicated. It's all right there. I don't need to transfer things back. If I'm going to be in this degraded state for a period of time, or not degraded state, but in the DR state for a period of time, I can go ahead and roll in physical systems at that point and start bringing those back online as needed. So this gives you the kind of the best of all worlds. You have very efficient backups, you have a fantastic ability to test, and then in the case of an actual disaster or server down, you have the ability to bring that data back or bring the service back very, very quickly. And that's really the big difference between most backup solutions and what we're talking about here and why we call it the recovery lie. Recovery is more than just moving data back to the original server. It is being able to return a service to the user. And so that's what we try to tell people to avoid in the recovery lie is recovery is not being able to copy data from point B to A. In the past, backups have been so bad that that actually seemed like a good idea. But now it's really about how can I get that service back to the user. And this type of implementation, because it provides real smart backups, a fantastic ability to test, as well as excellent overall recovery efforts when it counts, is the ideal situation. Thank you again for tuning in today. My name is George Crump, lead analyst with Storage Switzerland. I'd like to thank Quorum Labs for sponsoring this video.